Boom! Yes, folks, Hume here again. In this video, we're going to do a couple of things. We're going to illustrate the concept of flattening the curve. And in doing so, we will look at our own curve, the Trinidad and Tobago curve as calculated by me, using the figures provided by the Ministry of Health in the daily updates. And we have a nice little discussion going forward. So, what's all this talk about flattening the curve? It's a nice buzzy catchword, and you know how it is with humans, right? A lot of times you had to have a nice phrase that people could latch on to and run with, right? Social distancing is an excellent example of that, right? The general idea is to keep a distance from people. So instead of making a whole long paragraph, you say social distancing, and it takes us a little while to figure out the intricacies of implementing that in our daily going abouts, but we're getting better and we're doing it. Same thing for flattening the curve, right? Most people know that it have a curve somewhere that needs to flatten, right? And we know that when the curve flattens, that is a good thing, right? But we don't really, I mean, we have an intuitive understanding, a common sense grasp, if I could call it that, right? The whole law of common sense thing now. We intuitively sense that this curve, wherever it is and whatever it represents, when it flattens, that is a good thing. And we want that. And we basically waiting on the people who are monitoring these things to tell us, well, yes, the curve has flattened, right? Now, in my own personal capacity, I have been monitoring the figures, and I could use the actual figures to show you the curve and to illustrate the concept. But before we do that, I want to use a hypothetical example of something that we're all familiar with as Trinidadians and Tobagonians and West Indians, the whole concept of cricket. Because the concept of the average is what we're going to deal with. Because this curve that's supposed to be flattening is not just a curve of raw data, right? It is a curve that gives the average over a period of time. And when that curve flattens, then you know, well, all right, something good happening here. And when the curve start to dip and go down, then you could say, yes, we're in the game now. So, by way of illustration, if we have a hypothetical batsman, let me give him a random name. Let me just call him Brian, right? Just as a random name, you know what I mean? So our hypothetical Brian, batting for a hypothetical team, starts a hypothetical career, all right? And in his first inning, he scores 30 runs, which means that his cumulative score, which is the score over all the innings that he plays, is 30 because it's just one inning, right? And the average is 30. 30 divided by 1 is still 30. After his second inning, in his second innings, he scores 30 runs. So the cumulative score after 2 innings will be 60, 30 plus 30. So 60 divided by 2 is the new average, which is the same 30 that we had before. In the third innings, he scores 60 runs. So you take this 60 and add it to the 60 from the first 2 innings. That will give you a cumulative score of 120 runs over 3 innings, to give you a new average of 120 divided by 3, which is 40 runs, right? And then in his in his fourth innings, he scores 40 runs. So this 40 added to the 120 from before will give you 160 over 4 innings, for a new average of 160 divided by 4 to give you 40. And then in his fifth inning, he scores 20 runs. 160 plus 20 is 180. 180 divided by 5 will give you the new average of 36. So you see the movement of the average as the scores fluctuate, right? The average started at 30 and we move up to 40. And then with a low score of 20, it dropped from 40 to 36. So we continue. Inning number 6, he scores 36 runs, which we add to the 180 from here. And we now get 216 over 6 innings. So 216 divided by 6 will give you an average score of 36. And then boom, he hit a low point here now. He hit 1 run. So 1 plus 216 is 217. 217 divided by 7 is 31. So with this drop from 36 to 1, you see the average also dropped from 36 to 31. And then in the 8th innings, he back on the up now. He hit him at 23. So we move from 217, we add 23 to that, and we get 240. So 240 over the course of 8 innings to give you an average of 30. So the average still drops, even though his score improved from 1 to 23. The reason for that is because the final score that he made here is still less than the average from the games before. So anytime your score is less than the previous average, your overall average will drop. If your score is greater than the previous average, your overall average will rise, which is what happened here when he scored 60, which was more than the 30, to give you an average of 40, moving up from 30. And the same thing going to happen here now, because in his 9th inning he scores 39, which is more than the average of 30. So that 240 plus 39 is 279, and 279 divided by 9 is 31. So it's a small increase in the score from 23 to 19 to 39. He scored 16 more runs than he scored in the previous innings. The average only moved up by 1. And then boom, hit him a century here now. Excuse. So at 121 in the 10th inning, he added 121 to 279 to give you a score of 400. So 400 divided by 10 will give you a new average of 40. So in other words, to move his average from 31 back up to 40, he had to make a big score of 129. And that is the nature of Test cricket, of batting over a career in cricket, right? Maybe a one-day match might be a better example, because one-day cricket is just inning per inning. Test cricket is 2 innings per game and all of that. But forget it. The whole idea is that we did our example with respect to the innings. And just as a side note, right, more for Test, I'm not too sure about the one day, but in Test cricket I know that generally speaking, the great batsmen usually retire with an average of over 50, right? And the good batsmen, the very good batsmen, let me say the exceptional batsmen, will retire with an average of between 40 and 50, right? And then average of 30 to 40, I think, would be considered, what's the word I'm looking for? Fair or medium or whatever. But again, we have so many non-mathematical factors to consider, because sometimes, for example, you have a batsman might be a very good batsman, but he might be lower down in the order, which means that he doesn't get as many opportunities to score the big scores as the batsman higher up in the order. So in all of this maths, we always have to recognize that there are always non-mathematical factors at play that influence the final figures that we see. And that is the same thing with the COVID, right? So one of the factors we're definitely looking at is the number of tests that have been performed so far. And that is why up to this point we have been excluding what I call the boaters, the people from the cruise, because the number of tests have been small, right? After just over a month, we have had just about 700 tests, just about, right? So let me say 700 divided by 30, that's a little over 30 something, right? 30 something, 20 something, somewhere between 20 and 30 tests per day, right? Yeah, 30 by 20 is 600. Yeah, about 20 something. 25 by 30 is 750. Right, so somewhere between 20 and 25 tests per day, and an average. There have been days when you had 50 tests in terms of the difference between days. And then there were days when you had a difference of 20 tests. But on an average, you see that word again? The average is about 20 to 30 tests per day. I mean, that is severe under-testing, to quote one of my Facebook compares, right? But we have a situation now where the Minister of Health is saying that we're going to get to a situation in the not too distant future where we'll have up to 1,000 new tests every day. That is a horse of an entirely different color, because with all those tests coming up, we could expect to see a much truer indication of what is really taking place, right? Because we're hearing all these anecdotal incidents of people who have symptoms and they're not getting tested for whatever reason. If we now in a situation where we could test 1,000 per day, then we could minimize that and get a clearer picture of what's going on. But in the meantime, we have graphs to look at. So on the comments in this video on Facebook, you would see the nice pretty Excel version, right, with nice blue background and thing. I tried my best to reproduce it here, and I think this is a fair representation of what you have there. So the green line represents the raw scores with every successive update, and the red line represents the average percentage with every successive update. Let me repeat that again, just to clarify something I said there. The green line represents the raw percentage. So you have a certain number of tests and a certain number of positives. The percentage with each passing day would be the number of positives divided by the number of tests. Right? So this is the percentage. This is the movement of the percentage on a daily basis. This is the movement of the average on a daily basis. Two different concepts. Right? Now, even without the red line here, you can see the green line, and you see a general trend taking place. So here, for example, even though you have some fluctuations here, the general trend is for the scores to go up, which you would see reflected on the curve for the average. So the red line is the average curve here. And then watch it now. As the raw percentages start to drop here, you immediately see that the curve flatten out here. So this is essentially what we mean when we talk about flattening the curve. Because at the end of the day, the only way for that curve to flatten is if you have a sustained decrease in the percentages, in the daily percentages going forward. So in other words, if this decrease were to continue all down here, then at some point this curve will start to bend downwards. Right? So at that point it wouldn't just be a flattening of the curve, it would be a bending down of the curve. I guess they will find some nice phrase for that too. Right? So the phase that we are currently in now is the phase where we're looking to flatten. Right? That's the first milestone that we had across. We had to flatten the curve, and if we could sustain the flattening as long as we could, then eventually the curve will start to dip. But back to our own curve now. So in our case, you would have seen the flattening here, and you could check the actual curve in the Excel version just to be sure, right? And then in the flattening, you see a snap. It sort of swing upwards here, kind of very, very slight. So for all intents and purposes, you could consider this whole region here to be virtually flat. But then the percentages start to tick up here again. Right? So from this point here now, you start to see a general trajectory upwards. And of course, that too will be reflected in the graph for the averages. So the average graph starting to go up. So this here is the phase that we are in right now in Trinidad and Tobago. Alright, so as of up to update number 69, that is where we are. So of course, as the updates continue to come in, what I will do is plot in the figures, nice big Excel spreadsheet, and the spreadsheet just spreading, right? Because as more numbers come in, there's more things to add, right? Thankfully, we have the formula and thing. You just put in the formulas and boom. As you put in numbers, everything else come up. Technology is nice. Let me use it now, right? So this is the phase that we're in here. This is a dangerous phase. Because if this line continues to go up, then we're in trouble. So the longer this line continues to go up, the more we have to be concerned. Because let me say by April 15, this line is still going up. And what we're going to do at that point, the relevant authorities will have a decision to make. Do we extend the lockdown, or do we introduce some other measure, all in an attempt to flatten the curve? So we're actually looking for the flattening here. So the same thing that happened over here in the early days of this thing, and then we start to go up. The flattening is what we're looking for here. And if we could get this flattening taking place in a situation where we have a lot more tests being conducted, then at that point, you could start to exhale a little bit, because you could say, well, all right, something happening here. And then if you could sustain that flattening for as long as possible, eventually the curve will start to dip. It's like when you're fighting, right? And I use the analogy of a fight in my original caption to the picture, right? I said that the green line says we're in a fight, and you can see it here. Watch, up and down, right? We're fighting. We're still in that struggle. But on the balance of things, we are the ones that kind of losing right now, right? We're getting pushed back, right? But even though we're getting pushed back, we had to keep pushing back, because that is the only way that this curve will start to taper out here into a flat region. So we have to keep up all the efforts that we have been making up to this point to get this thing, to fight this thing, right? So we still are waiting the overall patterns that will be reflected on our regime of much more tests. That is where the real action will be, right? From a mathematical standpoint, and also from the standpoint of telling us exactly what happened. At that point, we might be in a much better position to just reintegrate, me personally, to just reintegrate the boaters into the overall projection. Because at that point, if we're testing 1,000 people a day, then 75 people on a cruise, we could just, that's just a drop in the bucket, so to speak, right? But until we get to that, we'll consider them as outliers. So, with this little video, first of all, before I go there, let me just finish explaining the analogy I was using here. So this here is the fight. We were losing up here, and then we started to push back, and then we started to lose again. Kind of like two boxers. And then I said the red line was saying that we still need night. That is the analogy of fighting. The whole analogy of dawn, of daybreak, of daylight. Of daylight signifying victory. Of dawn signifying, yes, we're starting to win this thing. And then the sun come out in all its glory, and we can say, yes, we're winning. We're on top now, right? So I use the language in a particular way, but here now is where I'm looking to try to meld the language with the maths, right? Maths is a language, right? We just say that all the time, it's true, right? So just to conclude and to wrap up now, remember, when we talk about flattening the curve that we're actually flattening is the average curve, right? And I would have tried my best in this video to explain it without going into the deep mathematical details of differential calculus and rates of change and blah, blah, blah. Forget that, right? That is add maths. That's not even regular maths anymore. That is add maths going up the road. But as I say, a lot of this is common sense too. Because at the end of the day, if a curve going up, and the curve we're talking about is a curve for the number of positive COVID cases, or the percentage of positive COVID cases, right? Then if it is any flattening on that curve at all, we know what that means. We know what that means. So even if we don't understand the maths behind it, just resort to the law of common sense. To quote the Prime Minister, to quote the Commissioner of Police, the law of common sense. And the application of the law of common sense is even more important in terms of our own personal behavior than it is in terms of understanding mathematical patterns and numbers and stuff. Because at the end of the day, let us, for the sake of argument, say you didn't understand anything I just said in the video, right? At some point, you will just have to trust the word of the authorities when they say, we're still in a dark place, mind your business. And then at that point, we'll just be waiting for them to say, well, all right, we're making some headway now. Fortunately, we are in a position where we have a transparent sharing of the figures so that the entire population now has the chance to be toe to toe with the government in terms of the patterns and in terms of the facts. And that is the beauty of mathematics, right? Once you have and once you have everything in a transparent, done in a transparent manner, there's no hiding, right? Once everybody working with the same figures, doesn't matter where on the planet you are, it doesn't matter what language you're doing the mathematics in, the conclusion will be the same, right? And as I tell my students all the time, you have a question, 3 people work in 3 different ways. Once each of those 3 people do what they're doing correctly, each of them will get the same answer. And a lot of things in life are like that too. All right? So, everybody, be in a P's and Q's. Do what it is you have to do. Don't do what it is you don't have to do. All right? Be safe, mind your business, and let me beat this thing together. Boom!